Hello, this talk is about the October's upcoming newsletter. I have published it already. I write my newsletters pretty early. And what I'd like to talk about is explain some of the details that I don't have time to write in my newsletters. So anyway, here's October 2024's newsletter comments. So I first say in my newsletter that in software development, we're talking about pure software development. How do we develop software? And this newsletter is about namespace. Namespace are the variables and how we get to values in our applications. Okay. Databases, data structures, documents, documentation, whatever it is, it's the knowledge we use to do our work. So the first thing I say is assume nothing. If you're a developer, this is purely developers, but for the end user it's actually more important. But for the developer, I talk about assume nothing, which is unfortunately about 90% of what we accomplish is through assumptions. We assume we know what the user's doing. We don't. We have these so-called subject matter experts. You're not a subject matter expert. You're not supposed to be a subject matter expert. And yet we somehow think that it's more important to determine by somebody who doesn't work there of what they're doing. That's not our job. Our job is to write software. So every piece of knowledge that we put in I'm talking about our current software technology. How do we develop software? How are our computers? Our computers assume everything. We assume how the hardware instructions work. We don't know. Not without seeing the exact code, the exact wiring diagram, the exact Boolean operations that they're performing. We make assumptions. We make assumptions on what our compilers are doing. We make assumptions on the logic that we approach. You know, I have to sort a table. I assume that it's only going to be so big. I assume that I have enough disk space. I assume my memory is not going to run out. I assume about 90% of the actual knowledge that I develop or I have to know before I write any statement. Okay, next I put a test question in, and basically it said write these words in alphabetical order. Well, a student kind of understood that, and so he took each word and put the characters of each word alphabetically, not the words. So this is our assumption that we know what the user is going to do. Is this answer correct? Yes. Possibly. I don't know what the teacher would do. But you as a software developer cannot make assumptions that this isn't what the teacher was teaching. Maybe that was correct for her class. And so it's really up to the developer not to make assumptions on the logic that they produce, but rather have designed their systems so that it's possible and set up so it's designed so that it can be modified to do this. Because this is basically the correct validation of this test would be just to sort them and see if that's a sort order that the student did. So that's a one line, and generally in most cases, if you did a bubble sort, you know, whatever kind of sort you would do, but you would just, you know, I don't know of any system out there that sorts characters per word. So you would have to write that, but that's what a bubble sort, or just an index sort by character could. Anyway, just, it's not our job to assume anything. It's our job to produce software that accomplishes the task that the user needs. So we have a lot of knowledge failures because of these assumptions. And actually we looked at looked at our basic foundation of computers, and it's bad. It is probably the worst designed system that is possible. I don't think I can get it any worse. So if you're developing software, you're stuck with these failures. We program in ASCII or episodic or some character coding, and that's the worst design for a character set possible. For one, we have 33 control characters. We only use 2 or 3 of them. We cannot use the other ones. The reason we can't use the other ones is because our editors won't let us see them. We could hard code some scripting / bullshit, but we need, and so you're constantly figuring out, okay, in this case, how do I separate it? Well, I'll use a comma, or I'll use one of the 94 characters that we actually have. So our ASCII, our keyboard, our teletype machines are not the way we should be programming. Unicode is an application with no purpose. Somebody designed that as an application. This is the way I'll organize, and I can write code that does that. That's not the way we should design our applications. So I don't want to use Unicode. I'm going to get rid of it. From a technical side, it doesn't really work. Not for the pure technical capabilities of Unicode. It does not work. For one, we can't even represent all the characters. We can have 1.1 million Unicode capable characters. Anyway, I could talk all day just on characters alone. And our numbers, our hardware representation of numbers is terrible. Anyway, so our number representation is terrible. It doesn't really apply. We don't have numbers. We have a range of numbers. And that is we have more failures in our designs than we can even imagine. We keep having new versions because we have 3 versions of our GPS system because we kept running out of time. Because time, there again, was hardware implemented as milliseconds or seconds or something from some date, and that's the stupidest thing we could do because that forces us into running out of time. Date and time should never be in there together because now we have leap seconds, which makes it even worse, so that we can't even determine what day we're in. We have 27 seconds, or last year was 20. I don't know what it is today, but and so they've gone, Google has, and most systems have gone to a fuzzy logic because they can't tell what day it is or what year it is. So these are our fallacies in just our pure logic. I went to Namespace, okay, I'm writing the compiler, and the compiler, basically, our current technology, our compilers are only hardware, are just fancy assemblers. That's all they are. They don't do anything, they don't have anything. Whether it's an assembler or one of these so-called high-level languages, it's the same thing. We add, subtract, multiply, and divide, compare, branch, and that's about it. We don't do anything else with these languages, which is ridiculous. Oh, you want to add? Well, I do A plus B, okay, that looks cool, that's a compiler. Or I could move A to register 1, B to register 2, and add, and I mean, all it's doing is saving some typing, but it's not improving the technology. Technology is identical. In the compiler needs to be, I don't even know if we want to use the word compiler anymore, because they're doing just hardware instructions. I want to get to logic. And the only way to get to logic is through a namespace. So a namespace is simply, like I said, the variables and structures and files and knowledge and information, databases, motors, whatever it is we have, our mouses and our monitors and all the hardware attached is just the things, the location and the things that we want to act upon. So with knowledge, we act upon something. Computers only perform actions. So with a namespace, our current namespace, I guess I should qualify this, with our current namespace is simply the programmer, you as a programmer, hard code in some variables. It's a name value logic. Here's a name, here's a value, here's a name, here's a value. One value, nothing more. And that's our concept of namespace. And it's only within that one application. It knows nothing about the rest of the world. Knows nothing about your hardware, knows nothing about the application itself, which is terrible. And so what I'm doing is I'm changing that technology. For one, it's universal. It knows everything. So it knows, if I put, I'm talking about the knowledge, putting knowledge into our system, and then putting a name to it and access to those values through a name. One name space, not 20 billion. Right now we have 20 billion namespaces. Every application, every data structure, is designed specifically for a particular application. I want the namespace to be applicable to every application, so that we have complete sharing of all of our information, knowledge, hardware. We want access to our hardware. Here's a mouse. And with the namespace, I want to know, okay, give me the X and Y of its current position, or, you know, what button was pushed, or whatever. I mean, this is the knowledge we need. We just have to go through 15,000 subroutines just to get these values. And that takes forever just to access information. So all of our hardware is going to be done, all of our logic, basic fundamental logic is going to be done by the compiler. Not functions. We're not going to apply functions to our compiler. They're going to be hardware instructions. They'll be back at the hardware, done by the compiler. So all these users, we don't have to done by the programmer. Actually, we can do away with the programmer once we get the namespace. Because if every value on the planet, every piece of knowledge on the planet and the universe is known, then there is nothing much for us to do. Okay, here's a picture. Okay, give me the X and Y. That, you know, give it to me by row, give it to me by column, give it to me by this range, give it to me in a set of ranges. And the possible logic that we can actually perform is very small on any piece of knowledge. Okay. So with the namespace, so everything's going to have one namespace. So all of our disk drives, all of our databases is just a namespace. Oracle, okay. I want the employees. And then I want all the knowledge that you have about them, those, and I want to qualify it. So in the namespace itself, it has qualifiers. So we have the namespace, we have the name or term that we've gone with the wind is a term, and the knowledge based upon that would be, oh, it's a book or a movie, and so all that knowledge we already know. We put it in our system, so any application that wants to know about Gone with the Wind, who produced it, who was in it, what was their role. There's billions of pieces of information about everything, and we don't have limitations on space. I was looking, I think, a 10 terabyte disk drive yesterday with what, $120 or something. I'm spending more than that at the grocery store, which is ridiculous. I hate going to the grocery store. Anyway, and so in the namespace, It's very, very complex, so that you can request anything that the system knows. So I want to know the parent, I want to know all the children, I want to know what line, I want to know the logic that this value was created. I want to know what lines that you reference this value. I want to know what lines change this value. Anywhere, if that's the information, if that's the knowledge I want to keep, and the system is designed to maintain this knowledge for you. So that in the namespace, it's actually much, much more than a namespace. It stores and retrieves your information anywhere, for any purpose. So we no longer have client-server technology. There is no such thing as client-server. We won't need it. We just say, look, on disk C of my hard drive, there's a file. Actually, I want to get rid of files and folders. We can still, when I say get rid of, change the technology so that it's not required. Knowledge is maintained for us so that we're not forced to memorize where I put my pictures from last Christmas. I can just ask the system, give me the pictures from last Christmas. That's our namespace, whatever it is we want. And so it's the knowledge, the name could be anything. People try and use names of things as organizational tools. That's why I want to that's why I want to get rid of files and folders. We can still use them. There's nothing wrong with them. It's just that I don't know of anybody who has lost files and folders. And, it's a stupid concept. And there again, well, I won't get into the capabilities here. Anyway, so with the namespace, what we're looking at is one namespace for all files and folders, so we can get to any file or folder, and we can get to any database, we can get to any piece of hardware and access it. Okay? Here's this application on the screen. Make a snapshot. That's all I need to say. I don't need to do anything else. That's enough knowledge for the computer to be able to accomplish that. So what we're doing is building custom applications. We only have one application, actually. That's what Jane is one application. So it maintains all knowledge. It maintains how to do integrals and physics equations and music and tell the user on exactly what's happening. So my conclusion was really in the technology is we only need one language. We don't, I went and looked at some PhD theses and they were talking about shared memory across processes and across machines and things like that. I won't eliminate all that, but I mean, he used 4 or 5 languages and scripts, and it was obnoxious. And he was using obsolete subsystems. Okay, and some subsystem he used, and I tried to find it. It had the page there, but it was no longer being supported. So, anyway. The namespace goes deep into the language itself. So, so every file out there, it's either going to be a script, a document, or a binary structure, or an executable, or something like that. The namespace actually is going to be accessible to the internals of every file. So if you have say a Python file and you say, let me see the functions, or whatever you want to call them. Every language wants to call it something else. I was looking at Spring the other day and it was like, oh, we're going to call them messages or something. I was like, okay. So anyway, we want one language, and that language can handle all the other languages. So we got 29 or 30 common popular languages, Fortran and Cobalt and C and Lisp and Python and R and C and G and Go and, you know, thousands of these little separate functions. They all do the same thing. So in this one language, if you want to put your Fortran programs in there, fine, it'll accept them. That's what I mean. We need one language that can handle it all. And then we have, you know, we have build routines, and that's going to go in there. So any action that you want to perform, so we no longer have like these DOS programs that do things. The language itself just does it. Okay, compile it. Save it off over here. Let me see this. Let me see that. And that's where we want to go. And then one namespace. So we have one language, one namespace. This is a little more complex than I can describe here, but the difference here is that our programmer-defined namespace, which is just variable name value, this namespace is context sensitive. So if I say elephant, it has all the information about elephants. And it knows, okay, you can say trunk and leg and country and all these other things, scientific name and whatever. And so that's part of it. But if I say elephant toenail, fungus, a little bit more specific. Now you're in context of, okay, I'm talking about an elephant, I'm talking about a toenail, and I'm talking about fungus. I already know, and you know, what could come next. We could be talking about doctors, medicines, veterinary clinics, world-renowned experts. The words that come next are in context. And that's what the system is going to do for us. It's going to put all this knowledge in context. Next, to really have our system, we want a full range of numbers. This, okay, 6 bits, and it's ridiculous. We need full range of numbers, and we can eliminate probably half of our failures. We need a well-designed character set. Our character sets are not designed with crap. I was looking at 2 different fonts, and they're 2 different sizes. It's supposed to be 12 point. It's not. It's based upon some internal stupid logic that they built, and so none of our characters are really consistent. We need consistency everywhere, so nobody has to worry about these kinds of things. We need one universal editor. Means that just like our language could have graphics in it, we need something that will edit the graphics. And we need it to expand we need to get rid of ASCII. We need to get something that is efficient in space, of course. But we're not worried about space so much. I'm more worried about perfection over space and time. We get it done. We can always optimize anything. So I'm designing for perfection, meaning that this is designed for a technology that can last forever without change. Everything changes. The technology needs to account for that too. Right now we can't change anything. So that's our whole issue here is, can we build systems that never change? Of course we can. Or is changeable. Meaning that I write a sort, maybe I come up with a new sort, maybe I come up with a new tree, maybe I have, maybe black-red binary trees and AVL binary trees, and I come up with a better one. Fine. Add it. It's a term. I'll call it Cliff's tree. Okay, fine. It's done. It's in there. You don't like AVL trees, and in this particular case, you as a human decide you want cliff trees instead of AVL trees. These are binary search and sort algorithms. I'm sorry for some of y'all that may not know. Okay. And we need a cumulative logic. That's the whole point here, is we're rewriting everything. I started programming about 48 years ago, 49 now, and I'm writing the same code I did back then. I've written some great stuff. I can't use it. I can't use it because I can't remember all the knowledge that I put into that program, and can I really use that somewhere else? No, we can't. We have to rewrite it to be precise. We can always reuse it if we spend enough time. We can always brute force anything. I'm just talking about system. I had a great scheduler. It did things by the day and the week and the month, and it had all the holidays in there, and it would have it was a work order management system, and it was great, and it worked on anything. It would work on, classroom schedules, and, meeting schedules, and anything that you want to schedule, reservations or whatever. But I could not, to get it out. This is why I started this. I want that in there, and I just want to say, put me a scheduler here, which is in our namespace. And so in anything, our technology must be accumulative to move forward, so that everybody's not writing this same garbage over and over again. And it's customizable by every user. So we can do away with programmers, because users is simply qualifiers. Give me a sort that, that ignores anything starting with J. It's in the namespace, and then that goes on. So anyway, I know there's a lot to this, but this is basically what I was trying to say in the newsletter. Okay, next month, in November's newsletter, I want to talk about a change to our document technology, so that we have one document technology for everything. So we can program in mathematics. Our whole technology really is a failure due to our lack of being able to represent knowledge. And so we need a document that can actually represent all knowledge in any form. And that way we can create better, and we could create 1,000 times better data structures. Anyway, that's it for this newsletter's comments. We hope to get rid of, move forward in our technology. Until next time, thank you.